So I really dislike chart libraries. And it's not because they're bad, it's because I have really bad experiences with them. My first job in the industry, I worked at Army Game Studio, and I had to build these like ridiculous charts with lots of animations and styles. And I apologize, Brad, he was the designer who designed these, but you made my life so difficult by demanding that they look and work a certain way. At my current job, I inherited a chart that looks like this. It's just a simple line chart. Like, it really shouldn't be that bad, but every time we upgrade that app's dependencies, this thing breaks. And it's just a struggle. So what's going wrong for me? Well, getting the design just right with a charting library can be very painful. You can spend a lot of time trying to get it to look the way your designer wants you to. It's hard to keep them looking and behaving right across upgrades. And I think that's partly because these libraries tend to be very configuration heavy. You pass in this massive config object to most of these charting libraries and hope you get the right result, and it's hard to keep track with what changes on that API when you're updating those dependencies. So at my current job, we had this big task to build basically like Google Trends, but for energy data. And it was wild design, custom tooltips, really interactive, and I'm like, oh no. I really don't want to build this using another charting library. But I don't want to build it myself either because, in my opinion, making my own chart seemed terrifying. There must be a reason why we don't build charts ourselves and always lean on libraries to get a good visualization. So I decided, you know what? Let me just spend a week or two and explore. It was time to face my own fears to see what it was really like to build a custom chart myself. But first, my name's Mike Ryan. I'm a software architect at a company called Synapse, where I'm working on making North American manufacturing more sustainable. I'm also a GDE in Angular and Web Technologies, and as mentioned, I am one of the co-creators of NGRX, a collection of open source libraries for Reactive Angular. So I want to make building visualizations in my apps a little better than what my current experience is. And if I'm going to do this, I want to build on top of the existing skill sets that my teammates already have. I also want it to be endlessly customizable. I want to have full and final say over how this chart looks and feels. And most importantly, when I upgrade my app's dependencies, it would be great if it kept working across those updates. So how are we going to do this? What big challenge do we have to overcome? Well, a new foe has appeared for you all to learn with me today, and that foe is SVG. So SVG is an XML-based vector image format. It allows you to describe the way a vector image looks using XML-like language. And what's kind of neat is that HTML is an XML-based language, and most modern browsers actually have support for you authoring SVG directly in the browser. So if we take a look at an example, I can use an HTML element, the SVG tag, and then inside of that SVG tag, I can use SVG elements. It's a whole new world of elements, but this one draws a circle with a radius of 200 pixels, whose center X is at 250 and center Y is at 250, producing the black circle on the right. But my mind was blown further when I realized that you can actually style SVG elements just using CSS. Custom SVG properties like fill or stroke, things that I've never even heard of before, you can specify in your application's CSS. And even further, SVG elements are part of the DOM, which means I can use things like query selector to get a hold of one and add some interactivity directly to an SVG document. So I'm like, okay, this seems pretty magic. Like I have this full language at my disposal for drawing interesting visualizations to the screen. I can style them with CSS, and I can make them interactive with JavaScript. Could I use them with Angular? And it turns out the answer was yes. If we take a quick look at one of an Angular component, we can use SVG directly in this component's template. There's one small trick. You have to tell Angular that it's an SVG element. So every time you see me use an SVG element today, I'm going to have to put this SVG prefix in front of the tag name. That's just letting Angular know that, hey, this isn't an HTML element. Don't try and make an HTML element here with this tag name. Make an SVG element. Then you can bind to properties of this element just using template property binding syntax. So I can have some piece of data, like the radius, and I can control the radius of the circle using Angular's template syntax. I can also use view encapsulation to style just this circle using the component's CSS. So like, okay, I think I'm onto something. I think I'm starting to get the pieces together for how I build my own visualizations. But if I want to build something complex, I kind of want to do it the Angular way. I would want to encapsulate behaviors inside of components. So I started thinking through, well, could I build custom components that run in SVG instead of HTML? The answer was yes, but there was a caveat. SVG, unlike HTML, does not support custom element names. So if I were to try and do something fancy like this and throw in a custom element inside of an SVG document, nothing's going to work for me. Browser's going to complain, that's not legal. But SVG does have this G element. And the G element stands for group, and it's basically like the div of SVG. You can put whatever you want inside of it. And what you can do is you can have custom attributes on elements. So I said, okay, here's what I'll do. Instead of using custom tag names, I'm going to author Angular components that target the G element with a specific attribute name. So let's take a look at how this might work. So I've got a component. It's just an Angular component, but there's going to be a few things that are different here. First is the selector. Instead of selecting a custom tag name, I'm going to select a G element with my custom circle as the attribute on it. And I'm going to put that SVG prefix in front of it to let Angular know that, hey, I'm talking about the SVG namespace here, not HTML. Now, my template is all SVG. I've completely left HTML. This is an SVG component. And I can use other SVG elements directly in this component's template. I can have inputs and outputs. We're just talking about Angular components now. And I can receive data and use that to control the way my visualization renders. I can also use the component's view encapsulation to style the way that these elements work. So this is feeling pretty great. I can make full Angular components that work in SVG instead of HTML. Now all I have to do is take this component, use it in an SVG document, and it'll render as I'd expect. So I think I've got enough pieces put together. I'm like, okay, let's take a stab. Let's actually try to build a visualization with this. So how do we go about going from that circle to a full-blown chart with SVG plus Angular? Well, I asked my designer friend, hey, throw together a challenging chart, and he did not disappoint. It's a little card, and it's got a spark line in it. And there's two things I want you to note. I don't know if you can tell in the projector, but the first is there's a custom tooltip animation. The little dots expand out at you. And there's a gradient underneath the spark line to give the visualization, I guess, depth. And so this is like one of those charts that should be simple to do in a charting library, but ends up being pretty complex to put together and have it work correctly. So let's try to build this with Angular instead. First, I like to think about the component hierarchy. What components do I have to create? So I have my application's root component, and it's going to consume what I'm calling the sparkline chart component. And it's going to pass down whatever data we want to actually plot using this sparkline. The sparkline chart component is going to create an SVG context, and it's going to start using SVG components inside of it. It's going to have one called area to show that gradient. It's going to have one called line to actually show the line that the user sees to visualize the data. And it's going to have a dots component, which is going to handle mousing over one of those dots, it appearing and showing a tooltip. The data flow is pretty simple, but what does the data actually look like? Well, we're just going to have the root component pass down a list of points to the chart component. And a point is going to have an x and a y. What value do I want to plot on the x-axis, and what value do I want to plot on the y-axis? So let's get the data wire together. Let's go to the root component, and the first thing we're going to do is we're going to inject a service. And this service is going to get us the data that I want to plot. It's going to get me the number of movies that are released per year in the North American movie market. Pretty straightforward data. Then what I'm going to do is I'm going to take that list of movies by year, and I'm going to map them into a list of points. I'm going to say that the x-axis on my chart is the year, and the y-axis is the number of movies released for that year. Now that I have my observable of a list of points, I can take those points and I can bind them to a points input on a sparkline chart component using the async pipe. So now that our root component is set up and we're passing points down to be plotted to the chart component, it's time to talk about the really tricky part here, which is actually plotting the data. And this was the part that's like, okay, this is where things must get complex. This is why we must use charting libraries. And it is complex. There's a good bit of math here, but it really was not as bad as I was thinking. So if we look at our card that we're actually plotting onto, let's imagine we're going to display some data on this. And first, let's establish a coordinate system so that we can talk about where to place things. In the top left, we'll have position 0, 0. X is 0 here and Y is 0 there. In the bottom right, we've got the width and height of our card, 500 by 120. What we need to do is we need to take some data point. So here I have the number of movies released in the year 2007 is 538 movies. And I need some way, some bit of math to take that year and say, okay, 2007 belongs here, 538 belongs here, therefore I need to draw a point at the intersection of those two lines, which belongs here. How can I actually do this math? And before we talk about it, I need to give you two new terms to learn, which is domain and range. Domain is the data that we want to plot. So for the data set that I'm talking about, I've got a list of years, 2002 to 2017. And the range is what I'm plotting that onto, which is, in this case, since we're talking about the year and the x-axis, it's just the width of the chart, 0 to 500. I always get these terms confused, so I like to think that the D in domain means data, the data that I want to plot, and the R in range must mean the result, the thing that I actually want to turn that data into. And to translate these values from the top, from our domain into our range, we're going to need what's called a scale function. What a scale function will do is it's going to take a year, and it's going to tell you which position to put that year in. So what does it look like to actually create a scale function? Well, we're going to have to create a scale function factory. That, given a domain and a range, my data and the result I want to project that domain onto, I can give you a function back that can plot that data. This is where the math is. This is all the math it's going to take to actually plot out this entire chart. So let's go through this line by line to understand. We're going to ask the user to give me two values. What's your minimum value in the range, the lowest value, here it's going to be 2002, and what's the maximum value, 2017? For the range, what's my minimum value? Well, my coordinate system starts at 0, and my maximum value is 500. That's the width of the chart. Then I'm going to take my minimum domain and my maximum domain and figure out what's the size of it. I'm also going to do the same thing for the range. What's the size of the range? And now I'm ready to return a scale function that can take a year and actually figure out where it belongs. And the way it's going to do that is going to take whatever value you pass in, subtract out the minimum domain, divide it by the size of domain. Using those values, we can now calculate which pixel to actually plot this on. So I know that was a lot of math, and I want to go through it one more time and actually evaluate this expression by expression to figure out what's going on here. So if I call this function with a domain of 2002 to 2017 and a range of 0 to 500, what's this going to actually compute? Well, the size of my domain is 15 because 2017 minus 2002 is 15. There are 15 total years in my data set. The size of my range is pretty easy to calculate. 500 minus 0 is just 500. It's 500 pixels wide. That's how many pixels we have to play with. Now, if I want to plot some year, like 2006, what I'm going to do is I'm going to take 2006 and I'm going to subtract 2002 from it. That gives me a result of 4. If I divide 4 by 15, which is the total size of my domain, that gives me basically like a percentage. What percentage point in my domain am I talking about? Once I have a percentage, I can just multiply that position or that percentage by the size of the range and tack on the minimum range, giving me, hey, 2006 belongs at pixel point 133. So we've got this ability to actually plot data now. That's the math we had to go through to get the plotter. Let's actually use this now and see if we can get some data to display. So first, we need to jump into that sparkline chart component. This is the first component in the actual visualization. And what we're going to do is the users pass us in a set of points, right? But those points are like year and number of movies released per year. What we need to do is we need to translate those into pixels to where we actually want to draw stuff. So I'm going to use a little utility function that I've written called getBounds. It just searches the list of points and finds me the minimum and maximum x and y in the entire list. And I can use that to create scale functions for the x-axis and the y-axis. For the x-axis, my domain is my minimum x value I found and my maximum x value I found, 2002 and 2017. For my y, my minimum value is going to be what was the lowest number of movies released across all those years, and what was the greatest number of movies released across all those years. Once I've got my scale functions for the x and y axis, I can map over each of those points and actually figure out, hey, where am I supposed to draw something? So I've done all the math I need, I've created those scale functions, and I've used them to figure out where to draw stuff. Now let's actually draw some stuff. So first, let's just draw some dots to figure out, hey, did we get even close? Does this look like we're on the right track? So I've got an Angular component here. This is an SVG Angular component, and it's going to have one input, a set of points. And this is the actual computed set of points. What are the positions where I need to draw something at? And from here, it's just Angular. I can use ng4 of that list of points and draw a circle for every point that I was passed. When I get a point, I'm going to set the center of that circle to be where the point was drawn. Once I've got the component done, I can add a little bit of CSS, and then I can go use this component inside of my sparkline chart. Now if I run the app, I've actually got my data plotted. All that math and then a little bit of ng4, and suddenly I'm starting to show data in the right position on this card. But we don't just want to show dots. We've also got to show a line going through them, and we have to do that little gradient business. So how do we do paths and polygons with SVG? Well, it gets a little magical here. SVG has a path element, and it has a D property on it. It stands for dark incantation to draw a shape. Or at least that's what it looked like to me the first time I saw it. It actually turns out that this just means a list of commands to draw a path. So the path command syntax is you have a function, and then you have some arguments to that function. SVG paths support a number of functions, but we only really need to learn 3 today. The first function is im, and im stands for move. Almost every path you encounter in SVG is going to start with the move function. This is going to say, where do I want to start drawing? So I'm going to start drawing at 72, 0. Those are the 2 arguments. First is x position, second is y position. So start at 72 over and 0 down. Then I'm going to use the L function. And the L function stands for line. So line takes, again, 2 arguments, an x and a y. Where should I draw a line to from the previous position I was at? From here, we can keep drawing lines to build up a shape. But then there's one final command we need, which is z. I have no idea what z stands for. I couldn't find it. If you know, I'd love to know. But it means close the path. Wherever I am now and wherever I started from the very beginning, just draw a final line there. So you might recognize the shape. We've just drawn the path commands to draw the base of the Angular logo. So it looks like dark wizardry. Once you unpack it and understand the syntax, it's like, oh, I'm just moving and drawing lines between coordinates. So I could write a function that does that. If I had a function called getPathCommands for line, and it took a set of points, then what I would need to do is I would first destructure that list of points into 2 pieces of data. I need the first point, and I need all the points after that in an array. And the reason for this is because I'm going to use that first point to do that im command, move. I'm going to start my drawing context at whatever the very first point is that I've received. Then for every other point after that, I'm going to use the L function, which stands for line, to draw a line in order. So now given a list of points, I'm going to create a command that will draw a path that just draws a line through those points. So let's try it out. Let's write an Angular component. Again, this is an SVG component, and it's going to have really straightforward functionality. I'm going to have an input called points. It's going to take a list of points. This is the data we're trying to draw. And it's going to say, hey, give me the path command to draw a line through these points. It's going to store it off on a property, and then I'm going to bind that property to the D attribute on a path element. That's all I have to do to now draw a line. I'm going to take this component, I'm going to slap it into my sparkline chart components template, and then I'm going to run the app again, and I've got a line passing through my points. I'm starting to feel like I'm pretty good at this. Only thing that's left is to really draw that gradient beneath that line. So I don't need a line this time, I actually need a polygon, right? I need it to go through all the points, and then I need to like draw a box beneath the bottom part to fill it in with a gradient. Well, we saw how to draw a polygon earlier, and in fact, we can actually start with some of the code we've already written. So if we wanted to get a path command that drew a polygon, we'd first start by taking in a set of points. This should start to feel pretty familiar. But then I'm going to reuse get path commands for line to get me all of the commands I need to draw a line through each of those points. Then I'm going to use my get bounds utility to find my minimum and my maximum x and y's, and I'm going to use them to draw two lines. The first is, so I've drawn my line through all of the points. Now I need to draw a line to my bottom right, and then a line to my bottom left. That will close off the polygon, or get me close enough, so now I can use the z command to close it up. So I've got my function to draw a polygon. Now I need to write my area component. Again, it turns out it's really not that bad. I'm going to do the same thing I did last time. I'm going to have an input of points, pass in some points, get my path command to draw that polygon, and then I'm going to bind that polygon's path to a path element. I'm going to take my new component that I've written, add some CSS to do that fancy gradient fill, and then I'm going to slap it in my sparkline chart component, run the app again, and now I've got my fill beneath the line. I'm really close now to having built the chart that my designer wanted me to build. But what it's missing is that when you're not supposed to actually show the marks. You're supposed to have them like appear when you hover over it and show a tooltip. So it's like, okay, let's figure it out. How do I do tooltips? Well, before we do the tooltips, let's get the little behavior right to where they only appear when you hover over one. Let's go into our dots component and let's figure out how to do this with SVG. And you already know how to do this with SVG because you're going to do it with just CSS. So we're going to take the styles for this circle and we're going to throw on some pretty familiar CSS attributes. I can set the opacity of a circle just like any other element, and I'm going to start the opacity at 0. I'm going to use a transition property so I can transition the opacity so that when the user hovers over a circle, I'm going to animate it from an opacity of 0 to an opacity of 1. Again, I'm just leveraging things I already know. I'm using the CSS skill set that I've built up over all this time. Now when I run the app, I've got the behavior I was looking for. Those dots only appear when I actually move my cursor over them. Now it's for the really hard part, though, that tooltip. Let me go back to the point interface that we started with from the beginning, and we said that a point was an x and a y. Let's expand this ever so slightly and say that a point is an x and a y and some kind of message to show in the tooltip. We're going to have to go back to our root component now, where we're mapping over each of those movies, and we're going to say, okay, your x is the year, your y is the movies, but now your tooltip is this message. I'm going to want to show the user, hey, there's this many movies in this year. So I've got all the data wired up. I know what tooltip to show, but how do I show the tooltip? Again, we can just leverage Angular here. I don't have to do anything special. I'll just reach for Angular material and use Mat Tooltip. Why not? It's an Angular app. I can use the things I've already got at my disposal. Now if I go run the app, it just works the way I'd expect it to. You hover over a circle, and now we're just going to show the tooltip using all the skills that we've already learned. So I'm feeling really great about this because I think I've set out and achieved the goals I wanted to accomplish. I have built on top of existing skill sets. Other than that little bit of complex math, this was just some templates, some styles, and passing data around using inputs. It's got endless amounts of customization because since this is an SVG visualization and I can use CSS to style SVGs, I can endlessly change the way this thing looks. And I think that this is built to last well into the future because I didn't use any other libraries. I just used my experience with Angular. And I was just using Angular features like template syntax. So if you know Angular, it turns out you can make visualizations on your own with a low amount of code that look any way you want them to by leveraging SVG. So go play with the slides and a working example. You can clone this repository now, dig into the code, and start playing with your own visualizations. Thank you.